Hello dear student, hello dear student, hello dear friend, hello dear student. So today class, welcome to physics by Mahato sir. Today class, unit and measurement, chapter 2, dimension analysis. So to complete here lecture today, dimension analysis. Here, today now we start here lecture. Dimension analysis. Dimension analysis. Chapter 2. Unit and measurement. Now start here. Basically to find today lecture physical quantity, dimension formula, the some physical quantities. Now here 7 fundamental quantities here. So 7 fundamental quantities here. Now consider first mass. Mass measured by m. Mass measured by m. Length measured by L. Time measured by T. Then again electric current. Electric current measured by A. Then next temperature. Temperature measure K. Temperature measure K. Luminous intensity measured by CD. Then third amount. Then next is amount of substance. Amount of substance measured by mole. So basically these 3 fundamental quantities most used: mass, length, time. These first 3 physical quantity mostly 3 fundamental quantities, 3 fundamental quantity mostly used dimension analysis. So now here start. So now here start dimension of the various physical quantity. Then here, so here 7 fundamental quantities. Mass measured by M, length measured by L, time measured by T, electric current measured by A, temperature measured by K, luminous intensity measured by CD, amount of substance measured by mole. Then find here now. So now first here, first velocity. First is here velocity. Velocity here. Velocity is first velocity. Velocity is distance upon time. Velocity is distance upon time, or velocity is displacement. Velocity is displacement or distance. Velocity is v equal to s by t. We know here v equal to s by t. S is the displacement. S is the displacement. T is the time. So now here velocity equal to displacement. Velocity equal to displacement upon time. Now here, so displacement is a length. Displacement here. So now here velocity first here velocity. So velocity here first is velocity. Velocity formula. Velocity equal to displacement upon time. So displacement mean is a length. Displacement mean is a length. Time mean is a time. So now displacement. So displacement is a length. So dimension is L. Time is T. Dimension is 2T. Then L T minus 1. LT minus 1. Here M is absent, mass is absent, so we write M0 L1 T minus 1. So velocity dimension here. So velocity dimension 0 1 minus 1. So mass is 10 length is 1, time is minus 1. This is the basically so this is the dimension. This is the dimension. Mass is here. Mass is 0. Length is 1. T is minus 1. T is minus 1. Here mass is 0. Length is 1. T is minus 1. The next here. Basically, dimension of the physical quantity, 7 fundamental core. Here, this is the power. This is the power of the fundamental quantity. This is the power of the fundamental quantities. 0, 1, minus 1 is the power. Of the 7 power of the fundamental quantities. So this is the dimension. This is the dimension. Second here. Second momentum. Second is momentum. Second is momentum. Here now momentum. Second is momentum. Momentum mv. Momentum mv. So here mass dimension is capital M. Velocity here. Velocity is dimension here. Velocity dimension. Velocity dimension L t minus 1. So m1 L1 t minus 1. m1 L1 t minus 1. Velocity dimension m1 L1 t minus 1. So momentum dimension here m1 L1 m1 L1 t minus 1. Power of the here power of the fundamental quantity is the dimension. Next, here next acceleration. Acceleration is change in velocity, change in velocity, change in time, change in velocity upon change in time, change in velocity, change in time. So change in velocity in change in time, change in velocity in change in time. So next physical quantity is acceleration. Acceleration is velocity, change in velocity upon change in time, change in velocity in change in time. So velocity is displacement upon time. Velocity is displacement upon time, and time is time. So here displacement dimension L, t dimension t, t dimension t. So L t minus 2. We write here m0, here m is absent, so m0 is 1, mlt minus 2. Dimension of the acceleration. Complete. Then dimension of next here is here 4. Next is here dimension of force. Dimension of force. Force is mass into acceleration. Force is mass into acceleration. Mass is m, acceleration is a. Mass is m, acceleration in a. So mass is m, acceleration here acceleration is a for acceleration. directly put here, directly put m is dimension is m, or acceleration. Here acceleration is change in velocity, and change in time, displacement upon time, displacement upon. So here m0 lt minus 2, acceleration dimension lt minus 2, acceleration dimension lt minus 2, acceleration dimension lt minus 2. So here we write m lt minus 2. So force dimension here, force dimension ml2. This formula is basically mostly used. So dimension of the formula must be remembered. Force dimension is mlt minus 2. Basically most time useful dimension formula mlt minus 2. Totally 4 quantity, physical quantity. Then next here is next physical quantity here. Today lecture unit and dimension first, and chapter 02, class 11. The next here, the next physical quantity 5, pressure. Pressure, force per unit area. Here pressure is force per unit area. Pressure is force per unit area. Pressure is force per unit area. So basically here force dimension, maximum time is, or so on. So and so force dimension basically most time is full. So remember this formula mlt minus 2. Now put here pressure is force per unit. Pressure is force per unit area. Pressure is force per unit area. That means force is pressure is F upon A. So force dimension here. Now here force. So force dimension now put. Force dimension now put M L T minus 2. Force dimension is MLT minus 2. Dimension of area. Here dimension of area is length into length, that is L square. Dimension of area. So length is dimension of L. L is area. Then area is L square. L into L is length into length is L square. So here L is cancelled. So M L minus 1 T minus 2. This is the dimension formula of pressure. So pressure, here pressure dimension M is change 1, M1, length is M is measure 1, length is minus 1 per, basically fundamental quantity per range. By so 7 fundamental quantities, 1 minus 1, 1 minus 1 minus 2, 1 minus 1 minus 2, 1 minus 1 1. So mass for 1, L for minus 1, T for time for minus 2. Then next here, next physical quantity here, number is 6, work done. work done. Work done. Force into displacement. Work done is force into displacement. Work done is work done. Work done is force into work done is force into displacement. Suppose here, suppose a body here F force applied, then displacement S, then work done F into S. Work done is force into displacement. Now here force dimension, we write force dimension M L T minus 2, displacement dimension L. So work done dimension is M L square T minus 2. Work done dimension M L square T minus 2. Unit is same, so dimension is same. Work dimension is energy dimension joule, work dimension joule. Energy dimension joule, work dimension joule. So next, seven, work dimension, work unit is joule, energy unit is joule. So unit is same, so dimension is same. Energy, so energy dimension M L square T minus 2, because energy and work, because energy and work unit is same, so dimension is same. Work and energy same dimension. Next, kinetic energy. So kinetic energy mean energy. So kinetic energy dimension M L square T minus 2. Complete. Kinetic energy dimension M L square T minus 2. Potential energy dimension M L square T minus 2. M L square T minus 2. M L square T minus 2. Then now completely erase. Here. Then 10, 9, then 10. dimension formula now find it here. Surface tension. Surface tension. Surface tension. Surface tension force per unit area. Surface tension here F. Surface tension force per unit area. Surface tension is force per unit area. So force dimension M L T minus 2. Force surface tension formula force per unit area. Force per unit area. So force per unit area. So force formula MLT minus 2. Length L, dimension is L. So L is cancelled. So M L0 T minus 2. So M0 L here L is cancelled. So L is absent. So L0 T minus 2. So surface tension dimension M1 L0 T minus 2. Basically dimension fundamental quantities per. Here per M is 1. M is 1. M is 1. L is 0. T for T is minus 2. 11. Moment of inertia. Next is moment of inertia. Moment of inertia. Moment of inertia. So now moment of inertia definition. Moment of inertia. Force in moment of inertia definition. Mass into perpendicular distance. Mass into perpendicular distance. So moment of inertia mass into moment of inertia I formula is m into r square. Moment of inertia denoted by I. So moment of inertia formula mass into distance square. So m is mass, r is length. So m into d square. M into d square. This is the formula of the moment of inertia. Moment of inertia formula m into r square. So every physical quantity formula remember, then easily find out the dimension. Find out the dimension. All physical quantity easily found out from the from this formula, from this every quantity basically formula dimension. Formula is used and find out the dimension. Next is moment of inertia. So now here mass is m. So formula पता होगा तो so then formula पता होगा then dimension easily find out. formula pata hogo to dimension easily find out. So mass is m, distance is L square. So m L square T0, L square T0. Then 12 torque is force into perpendicular distance. Torque is force into perpendicular distance. So force dimension m l t minus 2, perpendicular distance means l, so dimension is l. So here m l square t minus 2, m l square t minus 2. M L square T minus 2, M L square T minus 2. Torque dimension find out here. Now 13. Stress. Then next is stress. Force per unit area. Stress is force per unit area. Force per unit area. So force per unit area. So force dimension m l t minus 2, m l t minus 2. Area is L square. So m L minus 1 T minus 2. This is the dimension. This is the dimension of stress. This is the dimension is the stress. Then stress dimension formula m1 L minus 1 T minus 2. Then next strain. Then next is strain. Strain is change in length by change in original length. Change in length by original length. Change in length by original length. So change in length by original. So length change is length change is length. Here length change is length, so length del length, तो length में length is del change in length, so L, so dimension here change in length, so the length dimension L, here length dimension L, so L0 mean 1. So strain here, so dimensionless quantity. So dimensionless quantity, some physical quantity is dimensionless quantity. Any physical quantity, any physical quantity dimension is dimension is 1. So dimension is 1, so dimensionless quantity. When two same type of physical quantity, physical quantity, then dimension formula 1. This is the dimensionless quantity. So strain is dimensionless physical quantity. Strain is dimensionless physical quantity. Dimensionless quantity. Strain is dimensionless strain is dimensionless. So complete. Now same type of physical quantity, same type of physical quantity ratio form, same type of physical quantity ratio form, same type of physical quantity ratio form, then dimension is 1 or dimensionless quantity. The next year, refractive index here, then Next is refractive. Refractive index. So refractive index is split in medium 1 in speed in medium 1 upon speed in medium 2. So here speed in medium 1, speed in medium 2. So velocity cancel. So dimension is m0, l0, t0. So refractive index is dimensionless quantity. So refractive index is a dimensionless quantity. Dimension. So refractive index here m0, l0, t0. The refractive index is dimensionless quantity. Potential difference for work done per unit charge. Potential difference is work done per unit charge. Work done per unit charge. Potential difference is work done per unit charge. So potential difference work done per unit charge. Work equal to work is force into displacement. Charge here q dimension we know I current is I equal to q by t, then q equal to I into t, then here q is I into t. So work done is force into displacement. So force dimension m l t minus 2, displacement dimension l, a dimension, current dimension is a, t dimension is t. So m1 L square t minus 3 a minus 1. This is a dimension of potential difference.